The world is always changing. Today, one technology in particular is accelerating this change. Artificial intelligence, AI, is speeding up the way the world is changing. It is even changing the way the world is changing. We wondered, where should we start the journey to understand the AI landscape? Where to find answers to your questions? What is AI? Can machines think? Can a machine equipped with an AI show creativity? How does AI help humanity? Can AI help us with COVID-19? Can AI help us to make strategic decisions? Many questions we had to ask point to one place where scientists are pushing their cutting-edge findings: the IEEE transactions on artificial intelligence, or for short, IEEE TAI. You will be listening to some of the authors and the leadership behind IEEE TAI, explaining how AI is changing all of us.
Defining artificial intelligence is a non-trivial task. Imagine I ask you, what is a human? We all know a human when we see one. But to define what a human is, it can be a long philosophical debate. It is the same way for defining artificial intelligence. It has been a long philosophical debate.
In April 2021 editorial, you had two definitions for AI. The first definition was artificial intelligence is the automation of cognition.
We needed guiding definitions in the transactions so that we can define the scope. This first definition covers artificial intelligence from a technological lens. Computer scientists, engineers, and technologists, they are all designing algorithms and systems capable of automating one or more cognitive functions, such as memory, recognition, planning, vision, and conversing. We are also interested in metacognition in the transactions, such as creativity and motivation. We don't see cognition as a characteristic just for humans. We also, in the transaction, recognize animal cognitions, the distributed cognition embodied in a social system, and different forms of artificial cognition that augment humans, animals, and social cognition.
You also had a second definition of AI, which was drastically different. You brought to this definition dimensions of social integration of AI, but most people see AI as just a technology, is it not?
Artificial intelligence is more than just a technology, algorithms, and systems. It is a social participant. Artificial intelligence is a social participant. This definition invites scientists who are interested in ethics, social integration of artificial intelligence, human AI interaction, and distributed cognition to contribute papers to the IEEE transactions on AI.
Most people are more concerned with how can AI help us in the problems we are faced with today. And nothing is more paramount today than COVID-19. Data science is a branch of AI focusing on making sense of data to improve our abilities to solve complex problems.
So one of the first papers published in IEEE TAI is Leveraging Data Science to Combat COVID-19, a comprehensive review. Can data science help us in COVID-19?
We wanted to understand the landscape of how artificial intelligence is contributing to COVID-19. The standard approach in academia is to conduct bibliometric analysis to analyze the response, in this case by the data science community, to the COVID-19 pandemic. Clearly, previous global pandemics largely predate the internet and online access to much scientific research or rapid tools for analysis.
We're talking here about thousands of papers and hundreds of authors. How can one even comprehend and make sense of this space?
So we discovered that the number of papers and people working in the area is huge and beyond classic bibliometric analysis. So we identified a large number of authors across the world who are familiar with various aspects of the landscape, brought them together and worked collectively to map out this landscape in our paper in IEEE Transactions on AI, so as to help the community to see where the effective work at the intersection of AI and COVID-19 was already ongoing.
So I'm sure you found many interesting contributions that data science and AI in general made to pandemics and COVID-19. What did you want to achieve?
We wanted to synthesize the landscape so that the paper will help future responses to possible global challenges, such as a pandemic or even climate change, to see the whole range of tools available from data science and AI, and hence to avoid reinventing wheels. For example, we identified that existing AI technologies could help people in developing countries who may not have access to recent information as a pandemic develops. And hence, this would help them combat the global pandemic, and give people in developing countries, therefore, access to these technologies is paramount.
For AI to make an impact in developing countries, and for people in remote and rural areas, these locations need to connect to the global network. 5G network standards were rolled out in 2019, giving people in remote and rural areas unprecedented access to the internet at high speed. However, even 5G is not enough. AI is pushing the boundaries of communication, and new solutions need to be discovered to maintain the world connected with the rise of big data and AI.
6G communication is envisioned to use AI, and specifically machine learning methods, to create next-generation intelligent communication systems. Machine learning holds the key for 6G communication.
I can close my eyes and see these software robots flying through the communication network and between computers. Is this what we are talking about here?
Yes, but not just that. Think also that there are many AI-enabled robots managing this new world of communication. And these AI-enabled robots are autonomously making all sorts of decisions on your behalf on how to optimize the performance of the network. Just think about how easy it will be that people in developing countries, remote and rural areas, are getting these smart communication networks powered by AI, available 24/7, to maintain them connected with the rest of the world, and to provide them with services such as telehealth with holographic capabilities.
Helping people with COVID-19, providing access to remote areas, and offering people in developing countries with telehealth facilities. These are all good stuff, but can AI go beyond these technologies to think and be creative?
So this was the central question in our paper in IEEE TAI. When we contrasted machine learning-based computational creative systems to human creativity, we saw opportunities where machine learning methods may allow creative behavior to emerge in machines. However, we also found some major challenges that yet naturally distinguish human from machine creativity.
So, are you implying that artificial intelligence may exhibit some form of creativity?
Absolutely. Being emerging does not mean that we can't design systematic ways to improve the creativity of AI, and that is what machine learning is offering. In fact, machine learning-based computational creative systems could promote creativity, not only in the arts, but also in companies and large corporations, where creativity sits at the heart of innovation.
Decisions on the adoption of artificial intelligence technologies are made on a daily basis in boardrooms of big companies. This made us wonder, can AI enter and get a seat in the boardroom?
Artificial intelligence can take many roles in the boardroom. For example, right now we have AI can listen to discussions in the boardroom and take notes. But what we've been looking at is a much more challenging and we think much more interesting problem. Our paper in Transactions on AI looked at a strategic decision-making problem, and it's the following problem. How can we incentivize individuals or collaborators to make decisions that are both rational from their own individual perspective, but also at the same time lead to outcomes that are desirable from the social or common good perspective?
This sounds like a problem we have everywhere, not just in the boardroom. It'd be fantastic to tell parents how to incentivize their children so that the children do what's good for their family.
This is a good point, and I certainly would not assume that children adopt the model of economic rationality that we use in our paper. That model of economic rationality, which is very common in artificial intelligence, is more suited to individuals and organizations that have the capacity to reflect on their own behavior and their own strategic decisions in a principled way. And also, of course, children will love each other and love their parents, and so they aren't the selfish, rational actors that we assume in our paper. We assume that the decision makers are acting purely in their own self-interest. So the good news in our paper is that we establish a formal model to be able to study these questions, and we've begun to study them. The bad news is that the computational complexity of these problems is very, very high, and so there's much more work to be done.
The IEEE Computational Intelligence Society has been covering the landscape of AI for decades.
Imagine that you have a technology that can learn anything, another technology that can optimize anything and make decisions in any situation, and the third technology that can explain learning and decisions made in a naturalistic human language. Can you see how powerful these technologies are? These are the classic focus areas in the IEEE Computational Intelligence Society.
If AI can learn anything, optimize anything, make decisions, and explain itself, are we reaching singularity? Will AI take over the world?
Of course not, at least for decades to come. When we say anything, we are saying any task that we define to the AI, what we call narrow AI. General and strong AI are supposed to solve novel problems that have never been experienced by the AI before, which is an incredibly difficult task with very limited success today. We cover the most exciting and successful AI technologies in the society that you would hear about in the news. Neural networks and learning systems, evolutionary computation, and fuzzy systems are the classic technologies in the IEEE Computational Intelligence Society.
IEEE CIS has a strong technical community covering theory, application, and emerging areas in AI. Our member works across the full spectrum of AI, including brain-computer interfaces, swarm intelligence, data science, and all sorts of AI applications you can think of, from computer games to health and education. We have a dedicated working group to look at ethics, legal aspects of AI, and social integration challenges.
Things can always go wrong even with good intentions. How do AI researchers mitigate for these risks?
Absolutely. Without good governance, transparency, and monitoring, indiscriminate use of artificial intelligence could lead to significant harms, discrimination, and injustice. A plethora of toolkits exist, but have seen limited grassroots implementation. We are adopting an approach where we evaluate ethical AI toolkits against business barriers to adoption, human-centric AI principles, AI lifecycle stages, responsible AI, and practical usability in order to bridge the principles to practice gap. We then provide businesses with a toolkit selection resource to ensure they address key ethical themes and can match their resources, skills, and priority areas for implementing ethical best practice.
If only I can understand this AI. Jim, as a human, I use words. When I say I love you to someone, I do not have in mind a mathematical equation, and I don't even know where to draw the boundary of what this love means. How can a machine even communicate to me when the language of AI seems to be the language of mathematics?
Hey, funny you mentioned this. Indeed, the very core language of AI is mathematics. But the good news, however, is that a scientist from Berkeley, Latvizadeh, developed a whole branch of AI known as fuzzy logic exactly to make AI understand words with ambiguous boundaries. Many scientists in IEEE CIS are developing solutions that can handle the ambiguity, ignorance, and uncertainty we experience in the real world and rely on words and natural language.
For the technical savvy listener, can you share some of those methods? What are they called?
We have many explainable AI methods. In particular, fuzzy systems is a major area with many approaches for explainable AI. We also have methods from our evolutionary computation researchers, such as learning classifier systems, genetic programming, and adaptive rule-based systems.
Artificial intelligence is not just changing humanity. AI is changing itself. The landscape of AI is changing as researchers and practitioners are unfolding the value AI is bringing to this new AI-enabled era. If you want to keep an eye on this vast, evolving, and exciting field, turn to the IEEE Transactions on Artificial Intelligence.